Here in Chapter 5, Section 1, we're going to be looking at descriptive statistics, including standard deviation. So let's start by looking at range and standard deviation. So let's take a look at this example. So let's imagine that you are a cardiac surgeon faced with deciding which of two heart pacemaker batteries you should choose. Because you must operate to replace a failing battery, it is important to choose the one that will last the longest. Assume that battery A lasts for a mean time of 45,000 hours, so that's slightly more than 5 years, and battery B has a mean time of 46,000 hours. We found that all of A's times were within 500 hours of the mean, but B's times were as much as 2,500 hours below the mean. So what would be our better choice? So what you have to think about here is not only these mean times of the 45,000 hours and the 46,000 hours, but you have to look at what we're talking about in this second bullet about how much they fall within the mean. So we have that A falls within 500 hours of the mean, and B somewhere as much as 2,500 hours below the mean. So looking at this, we need to think about what is grouped the closest together, because you do not want to put a battery in someone that could fail very quickly because the standard deviation is so large. So the best choice would be A, battery A, because all of the times were within 500 hours of the mean. The range of a set of data represents how far the data is spread out. So we can compute the range as follows: the max value minus the min value. So that's how you find range. It's just subtraction of doing your largest minus your smallest value. So here let's do an example of range. So doing this by hand, you're looking for your smallest. So we have 16, and we have a largest value of 97. So you're going to do 97 minus 16, which is 81. Now, standard deviation. So if x is a data value in a set whose mean is x bar, then x minus x bar is called the x's deviation from the mean. We can then combine the deviations of all the values in the set into a single value. That is called the standard deviation, and the formula is the square root of the sum of all x minus x bars squared divided by n minus 1, where n is the number of values in the set. Okay, so again, x is going to be the data value point, x bar is our mean, and n is how many pieces of data did we have. So we're going to find the standard deviation of this final grades example. Here we're going to walk through step by step doing standard deviation by hand, and then I will do a video of how to also do it in Excel. So the first thing that we have to do is compute the mean to find our standard deviation. So we need to figure out what is x bar. So to find that mean, we're going to add up all of our x values and divide by our n. And remember that n is 12. So if you do that in your calculator, you should get 78. And then we're going to have each of our pieces, so each of our x values, which is in this first column, minus 78. And that's what's going to go in the second column. So I'm going to do 95 minus 78 and then put this answer down here. So if you want to take a minute and fill in the second column, and then come back and you'll be able to see the answers. So once you have those values, then you need to square each one. So you're just going to do what is 17 squared, and you get 289, and then fill in that third column. So again, you can pause the video, fill it in, and then come back and you'll be able to see the answers. And once you have that, you need to do the sum of all of those. So just add up all, and you should get 5,604. And then to finish out our formula, remember our formula for standard deviation is the square root of x minus x bar squared over n minus 1. So we have the sum of all x minus x bars, and that is the 5,604. Our n is 12, so 12 minus 1 is 11. And now you can plug this into the calculator, and you should get 22.5711 as the standard deviation. The coefficient of variation is used when comparing two data sets with a standard deviation. The data must be similar and have comparable means. So to find the coefficient of variation, you can do the standard deviation divided by the mean times 100. So here's an example of comparing stock price. So just as a reminder, I'm going to write our formula up here. We have coefficient of variation is the standard deviation divided by the mean times 100. So suppose the mean closing stock for Apple Inc. is 123.76 and a standard deviation of 12.3. And then we have our Dell stock with a mean of 78.6 and a standard deviation of 7.2. And we're going to try to figure out which stock was more volatile. So let's look at Apple and Dell. So our coefficient of variation is going to be 123.76 over 12.3 times 100. You can just plug that right into the calculator. And I am getting 1,006.1789. Then let's look over here at Dell. So we have coefficient of variation of 78.6 over 7.2 times 100. And that gives you 1,091.6667. So which stock is more volatile? The one with the larger coefficient of variation, which is Dell. There is some homework practice you can do in your textbook. And then, of course, you have your homework for My Math Lab. And this is going to be your attendance assignment 2 this week, since we had a test at the beginning of the week.